Hello everyone, welcome back to Technical Mathematics lectures conducted by Vadhyar Online Academy. In this video, we will discuss another set of important MCQs from the topic calculus. We will discuss few previous year exam questions and we will try to solve them on the go. So let's get started. Let's see the first problem. If y is equal to log x to the base e plus log e to the base x plus log x to the base x, then the value of the derivative of y with respect to x at the point x equal to e is. So we are asked to find out the value of the derivative of this function at the point x equal to e. We are given four choices. Option A says 0, option B says 1, option C says e, and option D says none of the above. So you may pause the video and try to solve this question by yourself. Okay, now let's try to solve this problem. We may solve this problem in a three-step manner. The first step is to simplify this expression given here. Then the second step is to find out the derivative, and the third step is to calculate the value of derivative at the point x equal to e. Okay, so at first let's simplify this expression given here. So we have y equal to log x to the base e plus we have log e to the base x. We may rewrite it as log e to the base e divided by log x to the base e. Okay, so this is by using the formula log of b with base a is equal to log of b to the base e divided by log of a to the base e. Okay, so we may use this formula to simplify this second term. Okay, we may rewrite this term as logarithm of e to the base e divided by logarithm of x to the base e. Okay, now plus what we have here is log x to the base x. Okay, log x to the base x. Okay, now log e to the base e, this term, its value will be equal to 1. Similarly, the third term, log x to the base x, this term is also equal to 1. Okay, so we may rewrite the expression of y as y equal to log x to the base e plus 1 divided by log x to the base e plus 1. Okay, now let's go for finding out the derivative of y. So dy by dx will be equal to derivative of log x is 1 by x. So 1 by x plus, here we have 1 by log x. So its derivative will be minus 1 divided by log x the whole square into derivative of log x, that is 1 by x. Okay, now the derivative of the third term will be 0. Okay, because here we have a constant 1, so its derivative will be 0. Okay, so let's rewrite this expression. Dy by dx will be equal to 1 by x minus 1 by log x square into 1 by x. Okay, now let's calculate dy by dx at the point x equal to e. Okay, what we get is, when you substitute x equal to e here, okay, what we get is 1 by e. The first term will be 1 by e, that one minus, here we have log x. So log of e with base e, its value will be equal to 1, as we said here. Log of e to the base e, it will be equal to 1. So 1 divided by 1 square into 1 by e. Okay, in place of this x we will substitute e. Okay, so we get 1 by 1 square into 1 by e. So if we simplify this, what we get is 1 by e minus 1 by e, and the result is 0. Okay, so we get the value of derivative of y at the point x equal to e equal to 0. Okay, so 0 is the right answer. So in the options given, the right answer is given by option A. Okay. Now let's move on to problem number 2. The maximum value of the function f of x equal to 5x plus 3 in the interval minus 5 to 5 is. So we are asked to calculate the maximum value of the function f of x in the interval minus 5 to plus 5. Okay, we are given four options. Option A says 28, option B says minus 22, option C says 3, and option D says maximum value of f of x does not exist in minus 5 to plus 5. Okay, so you may pause the video and try to solve this by yourself. Okay, I hope you have the answer with you. Let's see the solution. The maximum value of the function f of x in the closed interval minus 5 to 5 is. So here you can see that we need not go for the conventional method of calculating the maximum value of a function here, because this function f of x is a linearly increasing function. You can see that it's 5x plus 3. Okay, it will be a linearly increasing function. So therefore, in the closed interval minus 5 to plus 5, the maximum value will be at the point x equal to 5. Okay, definitely it will be at x equal to 5 because this function is a linearly increasing function. Okay, so just calculate the value of f of x at the point x equal to 5 by substituting x equal to 5 in the function. So the value of the function f of x at the point x equal to 5 will be equal to 5 into 5 plus 3. Okay, so that will be 25 plus 3 and we get the answer as 28. Okay, so this way we may easily solve this problem because this function what we have here is a simple function which is a linearly increasing function, and therefore maximum value will be existing at the point where x takes the maximum value. So in the specified interval, f of x will be taking the maximum value at x equal to 5. Okay, so let's go back to the options. So here the right option is option A. The answer is 28. Okay, but here option D says maximum value of f of x does not exist in the interval minus 5 to plus 5. Okay, that is true, but with respect to our question, this option is incorrect because in the question it is asked the maximum value of the function in the interval is. Okay, so we are asked to calculate the maximum value of the function in the specified interval minus 5 to plus 5. Okay, closed interval minus 5 to plus 5. It's a fact that the maximum value of function f of x is not in the interval minus 5 to plus 5, but here the question is to find out the maximum value of f of x in the interval minus 5 to plus 5. So therefore here the right answer is option A. Okay, now let's see another problem. Let's see problem number 3. An integrating factor for the first order differential equation dy by dx minus y by x equal to x cube is. Option A says x, option B says minus x, option C says minus 1 by x, and option D says 1 by x. So we are asked to calculate the integrating factor for the given first order differential equation. Okay, so you may pause the video and try to solve this by yourself. Okay, I hope you have the solution with you. Let's see the solution. Here we are given a first order differential equation. We know that the general expression for a first order differential equation is dy by dx plus py equal to q. Okay, now if we have the first order differential equation like this, then the integrating factor will be equal to e raised to integral p dx. Okay, so here p as well as q are functions in the variable x. Okay, so using this method we can calculate the integrating factor of the given differential equation also. So from this equation we may write down the expression of p. P in this case will be equal to minus 1 by x. Okay, so p is the expression that comes along with y. So here we have y here, so what comes along with y is minus 1 by x. Okay, so the expression of p in this case is minus 1 by x. So this implies that integrating factor will be equal to e raised to integral of minus 1 by x dx. Okay, so that will be equal to e raised to minus of integral 1 by x dx. Okay, and we know that integral of 1 by x dx is log x. Okay, so we may rewrite it as e raised to minus log x to the base e. Okay, and this can be written as 1 by e raised to log x to the base e. Okay, and we know that e raised to log x will be equal to x itself. So we may rewrite this expression as 1 by x. Okay, so here integrating factor expression is 1 by x. Okay, so let's go back to the options. So option D gives the right answer, that is 1 by x. So with this we are coming to the end of this video. Okay, in this lecture we discussed few problems from the topic calculus. In the upcoming videos we will discuss few add-on questions from technical mathematics. So see you in the next video. Goodbye.